Alright, in our last video we discussed about firewalling in Mikrotik. We have discussed about a stateless and a stateful, and we have already discussed about some chains. We have already showed the environment. This is just an intro about firewalling in Mikrotik. In today's video we are going to check in more details about, first I'm going to show you why is it important to learn the chains and some common mistakes when you are creating firewall policies. But before that, I'm gonna dive deeper into the theories and I'm gonna explain most of this stuff that is already mentioned in Mikrotik Firewalling wiki page, because I personally already had a lot of issues understanding what is going on there. They didn't describe it pretty well, but don't worry, today I'm gonna make it so simple for you so you can go there and understand everything that is mentioned there. But be aware, today we will have a lot of theoretics. So I recommend you to listen carefully and be very sharp, have the caffeine and pump it up. Let's go and see how we can benefit of today's video. Okay, the first thing is I want to show you why is it important to learn the chains. Why is it important to know which one will be hit first? So I have created one example here. In our example, I have Mikrotik here. I have internet and I have a Linux server which runs web server, and I hosted an application. I have exposed this Linux server to internet. So that means anyone going to this address, which is, imagine this is my WAN address, will hit this address. So if I enter the Mikrotik address, I will hit my very secure site, which is hosted on my Linux. Now, I want to restrict it. You may ask why. So why do you create a destination NAT to expose something toward internet and then you want to block accessing to it? Well, I'll give you some example. Imagine you want to restrict access to geographical location. For example, people only from your country or a specific country should get access to this Linux server. Or you have some cloud-based services where you don't have any control over the cloud service. You cannot build an IPsec or any kind of VPN between your local instance and the cloud one. So you have to expose something which is hosted on your local server. You have some application, part of the application is running on the cloud, part of the information are local. So you want to expose it to internet, but you want to only limit it to the WAN interface of your cloud application. So therefore, you will put a limit on that one. You will restrict it. You will make a firewall policy to make sure that source address is only limited to that cloud-based application IP address. So, question. In this setup, I have already created a web server and I want to block access to this web server to a specific IP address. So what will be happen? As I mentioned, let us go through the firewall policies first. So I have a destination NAT. This masquerade is just for enabling internet access to this Linux server. This is not important at all, so don't consider it. And in my NAT tab, I have created destination NAT and set protocol TCP, destination port 80. Incoming interface is ether1. And then in action, I mentioned I want to do destination NAT. And I want to pass the traffic to this IP address, which is my Linux server, to port 80. So if I enter this IP address, I will be redirected to this IP address. So you learn how to make destination NAT, by the way. And this is the result. This IP address is for the Mikrotik LAN or Edge IP address. And when I enter it, I will be redirected to this Linux firewall. So Now I want to put restriction on this one. So I've come here in my filter rules. I made a new filter rule, and I said the chain should be forward and destination address is this address. So if anyone wants to hit this address, I didn't mention source address. This source address can be your cloud WAN IP address or your country geographical IP address. So I just generally want to block access to this server by everyone, so no one should get access. That's what I expect to get at the end. So I said the destination address, if someone wants to reach to this IP address and this port, the action would be to drop. That means you should not process this traffic. You should not send it toward the Linux server. So now this one is disabled. Because of that, we are able to reach to the Linux server. So I will enable it, and let's see which one will be hit first. What do you think? Will this drop filter rule prevent access into the web server or not? Let us think. Ready? Let's go. Apparently not. So that means the chains are very important. This rule is not doing anything. Why? Because the destination NAT is being processed first, and then after destination NAT, the forward chain is processed. So you have to know the chain orders to be able to efficiently block some traffics. Otherwise, you will expose your services to the internet, or you will not manage your network properly. That's very important. So by this explanation, we will understand the importance of the chains. Let's go to the theoretical part, and I will help you to understand what's happening in Mikrotik and how the packet flow is implemented in Mikrotik routers. Okay, this is very simplified of what happens in the background when a packet comes into Mikrotik in regards of the firewalling. Let me explain it a bit to you. When a packet comes in from physical interface, it has to make decisions. The firewall, the Mikrotik, has to make some decisions. Whether it should go to bridging layer 2, MPLS layer 2.5, routing layer, which is layer 3, or local. What is local? Local means the router itself. So we have some traffic that are distinct toward the local, or the source is local. It means the router itself is sending something toward the internet. You can also have a control over that traffic as well. So when it comes in through physical interface, it does make some decision here, which I'm just making a circle here. And if it detects it's a bridging layer 2, it will be forwarded to this one. If it is not, it will go to the next one, make some decision here. And it detects it is MPLS, it will forward it here. And the next step is the same, make some decision here. And if it detects as a layer 3 traffic, it will forward it here. Lastly, it detects it is destined toward the Mikrotik itself, so it will forward it here. But this is not the whole idea. If it comes to bridging layer 2 or MPLS or router or any of these, there will be some stuff happening inside those squares, and based on the chains that is followed, the packets will also go out toward the physical interface. So whether if it is this, that, or that, it will be forward toward the out interface, and out interface will send it out. And also there are some decision making here as well, but I just want to simplify it for you. Okay, this is the whole idea that is happening inside Mikrotik when a packet comes in. So you have also some stuff here which is regarding layer 3 VLAN interface, layer 3 VLAN interface, but I will describe it in more details lately. This is the whole idea, but if you go to Mikrotik website, you will see this one. This is the exact description of what's happening in the background. So you have physical interface, something happens, it will decide if it needs to go to bridge or to MPLS or to the routing, or if it is destined toward the router itself. And this is also logical interface, which I described earlier. So, and these are the decisions that needs to be taken when coming in or coming out, decapsulating or even the processes. So that's the whole idea. Each of this bridging, routing, and MPLS also, as I mentioned, have some stuff inside them. So they have bridge destination net, pre-routing, use IP firewall, bridge decision, forward, bridge source net, and so on. The routing also has some special chains which needs to be followed. MPLS also have some special chains and some decision making and some action. But more about these ones later on. So in RouterOS version 7, we have some default chains. The ones that we are seeing here are default chains. And I want to go very quickly over them. The pre-routing chain is responsible to apply the packets as they just arrive on the network interface. This chain is present in NAT, Mangle, and raw tables. The input chain is responsible for the packets before they are given to the local process. This chain, for example, is for Mangle and filter tables. Output chain is for the packets after they have been produced by a process, like raw, Mangle, NAT, and filter tables. Forward chain, the rules here apply to any packets that are routed through the current host. This chain is only present in the Mangle and filter tables. Post-routing chain is responsible for the packets that they want to leave the network interface. This chain is present in NAT and Mangle tables. Note that a lot of this information are taken from official Mikrotik wiki webpage. So you are learning something that is officially mentioned in their website. So let's start with the first one. Imagine the Mikrotik, the firewall, have decided it's a layer 3 forwarding rule. We have to follow a forward chain. So what happens? The packet enters a pre-routing process. It checks if there is a hotspot and modify the packet for hotspot use. This is what happens inside the layer 3 routing one. So maybe this one is better for you to follow the orders that I'm reading. B, process packet through raw pre-routing chain, and C, send the packet through connection tracking. The D one is process packet through Mangle pre-routing chain, and E, as the last part of this pre-routing processing, is to process packet through NATs and destinations NAT. And then the second step is to run packet through routing table to make routing decisions. The third step is the packet enters the forward process. For that one, we have the following sub-processes. A, check the TTL value, if it is still, there is a TTL value, or if it is more than the allowed one, then they have to drop it because there is a layer 2 loop. B, process packet through Mangle forward chain. C, process packet through the filtered forward chain. And D, send the packet to accounting process. So the fourth one will be a packet enters post routing process. I'm talking about this one. So the sub process is first A, process packet through Mangle post routing chain. B is to process packet through NAT's source NAT chain. And C is if there is a hotspot, undo any modification made in hotspot in. D, process packet through Q3, hotspot global. And E, the last one of the sub-processes, process packet through simple queues. And the 5 and the last step is check if there is IPsec and then process through IPsec policies. The next one is routing input. Yes, this one is about in interface that needs to be routed, and it's a bit complicated, let's say. This is what happens inside that square box that I mentioned. So let's go to the chains that will be followed. The first one is per-routing, this one. It is very similar process happens when a packet's destination is a router, like a routing input. So the first sub-process, which is A, is check if there is a hotspot and modify the packet for hotspot use. The B one is process packet through raw per-routing chain. C, send the packet through connection tracking. And D, process packet through mangle. There is also E, which is not here, process packet through NAT's destination NAT chain. There is a second one which is not here, but you can see it here. Run packet through routing table to make routing decision, because this is not regarding the chains that are in the firewall process, so you don't see it here. And the third one is a packet enters the input process. The sub-processes are mangle input, which is process packet through mangle input chain. And the next one is process through the filter input. The third one, process through Q3 or hotspot global. And the last one, the last sub-process, is process packet through simple queues. And the fourth one, which is again not here, but you can see it here, is to check if there is a IPsec and then process through IPsec policies. The next one is routing output. These are the stuff happening in routing output. So let's quickly go through them. Let me show you the chains that will be followed. Yes, so we have output. The packet goes through the routing table to make a routing decision, which is not here in this chain, but you have seen it previously here. Routing decision, this one. The second one, which is mentioned here as an output, process packets through the bridge decision, the A one. Process packets through the mangle output chain, process packet through the filter output chain, send the packet to routing adjustment or policy routing. This is also very interesting. The third one will be process packet through mangle post routing, source NAT, hotspot out, hotspot global, and simple queues, which already discussed about it. And the last one, the fourth one, will be to check the IPsec policy. Okay, let's move on toward bridge packet forwarding or flow of the bridge packet. This one is a bit easier. So when will we have this one? When we have multiple bridges, they want to forward packets to each other. The first one, the packet goes through the bridge NAT destination NAT chain, where MAC destination and priority can be changed. Apart from that, a packet can be simply accepted, dropped, or marked. The second step is check to whether the use IP firewall option is enabled in the bridge setting. The third one, run packet through the bridge host table to make a forwarding decision. A packet that ends up being flooded, like multicast, broadcast, unknown unicast traffic gets multiplied per bridge port and then processed further in the bridge forward chain. When using VLAN filtering, yes, packets that are not allowed due to interface bridge VLAN table will be dropped at this stage. The fourth one says a packet goes through the bridge filter forward chain where priority can be changed or the packet can be simply accepted, dropped or marked. The fifth one, check whether the use IP firewall option is enabled in the bridge setting. Again, the same. And the sixth one, a packet goes through the bridge NAT source NAT chain where MAC source and priority can be changed. Apart from that, a packet can be simply accepted, dropped or marked. And the last one here is to check whether the use IP firewall option is enabled in bridge setting. So this one looks fairly simple. And what if we want to do bridge input? In that case, we have these chains to be followed. The first one is bridge destination NAT, where a packet goes through the bridge NAT destination NAT chain. As I mentioned earlier, the MAC address and the priority here can be changed and also simply accepted, dropped or marked. The second one, check whether the use IP firewall option is enabled in the bridge setting. The third one, run packet through the bridge host table to make a forwarding decision. A packet where the destination MAC address matches the bridge MAC address will be passed to the bridge input chain. Pretty simple, pretty similar to the previous one, but there is a difference here. The fourth one is the difference. A packet goes through the bridge filter input chain where priority can be changed or the packet can be simply accepted, dropped or marked. So that's also about input. And let's check bridge output. Let me just show you these ones. Yes, better. In bridge output, we start with bridging decision, which is again running the packet through the bridge host table to make a forwarding decision and simply go through the bridge output chain. The second one is a packet goes through the bridge filter output chain where priority can be changed or the packet can be simply accepted, dropped or marked. The third one, packets goes through NAT source NAT chain where the MAC address source, the source MAC address and the priority can be changed and also can be simply accepted, dropped or marked. And the last one is to check if the use IP firewall option is enabled in bridge setting. Now, if we have forwarding with firewall enabled, it's a different story now. Let's see what happens here. First, a packet goes through the bridge NAT destination NAT chain. The second, it says with the use IP firewall option enabled, the packet will be further processed in the per-routing chain. The third one is the packet enters per-routing processing. The fourth is run packet through the bridge host table to make forwarding decision. Fifth one is about the packet goes through the bridge filter forward chain. The sixth one is when the use IP firewall option is enabled, the packet will be further processed in the routing forward chain. And the seventh one, a packet enters routing forward processing. Eighth is the packet goes through the bridge NAT source NAT chain. Ninth, check if use IP firewall option is enabled. And 10, going toward post routing processing. This is also mentioned here as well, so it's kind of the same chains that we have. Let me zoom out, now it's better. Now you can see all the chains that are being followed here. So the next one is MPLS, which is the last one in our video. we go through the pop label process. What is a pop label process? At the egress of the MPLS domain, or when the label indicates that the packet should be decapsulated, the pop label process happens. The outer MPLS label is removed, exposing the next label or the underlying IP packet. After popping, the packet is treated similar to a non-labeled packet, which may then be routed or sent to local input, or if it is a destination, can be sent to the destination. So a pop label packet would go through pre-routing, MPLS decision, pop label, then routing decision if it is still needed, and then forwarding or input chains and etc. But this is not all about MPLS. I limited to this one. Maybe later on I will make videos if you request it. But let's move on. The switch label happens for the packets arriving with an MPLS label and which are being forwarded through the MPLS network, not egress or ingress. So packets that remain within the MPLS domain and are not ending at this router, this label will be swapped. So this, because of that, they call it switching label. And what happens here? The router does an MPLS forwarding table lookup, giving the incoming label, possibly what outgoing interface should be, and then it switches the label. Wherein the flow happens after pre-routing, after the routing or MPLS decision in the forward chain if the packet is being forwarded. So first MPLS decision, then forwarding, and that's it. That's why MPLS is so fast. The next one is push label. So let's go over through this one. When should we follow push label? When at ingress to MPLS domain, or when you have an IP packet that needs to be encapsulated into MPLS. In another word, when entering the MPLS domain. What happens here? A new MPLS label is pushed or added. By pushed, we mean added on the top of the packet's payload. This could be applied even if there were existing labels, like stacking. The packet then goes through MPLS forwarding like a labeled packet. So first enters here, then the push label is added, then it is forwarded into MPLS network. So I would like to keep it simple and conclude it here. Bear in mind, this is not all about the chains and what happens at the backend, because we have some special cases when you enable VLAN filtering, or you want to do fast forward, or you want to do hardware offloading. But I will explain those ones maybe in the future in another video. Let's move on and learn about some common mistakes when we are creating the firewall rules and policies in Mikrotik. Let's go. So let's continue with common mistakes when creating filter rules. The first and the most common one is when you want to restrict access to SSH through WAN interface. So in this example, I have 192.168.247.130 as my WAN IP address, which is exposed to internet. And I want to restrict access to that one. Now, if I may try this one first, if I do an SSH to this one, I am able to get access through the SSH. Now I don't want to try it. So I have created a filter rule, and in my filter rule, I would say the chain forward, protocol TCP, destination port 22, and in interface is ether1, which is here. And I set the action to drop. So I expect SSH to be dropped and not be processed. And let's see if this is the case. What do you think before I try it? I know you have listened carefully today and you might already know what happens. So if I retry it, voila, I still have access. And what's the issue here? Why is it not applicable? Why is it not working? Because as we discussed, forward chain is to forward traffic to another device on the network. If you want to restrict access toward the Mikrotik itself, you should choose input chain. Therefore, you cannot do any SSH anymore. So if I stop this one, yeah, done. 192.168.247.130. Yes, I cannot SSH anymore. And I should get a hit count here. Yes, the packets are going up and up because it constantly tries to hit and do SSH. It tries to do more SSH. All right, the next one is blocking access to certain websites. So to do this, you have to create address list because you cannot directly input a DNS record inside your filter rules. So I created the address list and I named it block website, and I just typed address www.google.com, and it already detected all the addresses that are redirecting toward google.com. So inside my filter rules, I created a filter rule with drop action, and I said if it is going toward ether 1, which is in this case my interface toward internet, and if you want to go toward that one, and drop the traffic. So what I expect is to drop my traffic if I try to reach toward google.com, which is not the case here. Why? What's the issue? We already discussed about input and output and other chains a few minutes ago. The output chain is not talking about traffic going out of the router. That one, because the traffic is sourced from internal network, then the type of the chain would be forward. So output is actually from the router, input is toward the router itself. So in this case, to be able to block access to certain website, we just need to put the chain into forward, and then we should lose access to the website, which is the case. Now, if I wait, I cannot load it anymore. Let me just try it one more time with the clean top so you don't get confused. And as you can see, it doesn't open and I get heated. Yeah, I got hit here. I hope you enjoyed this video. I will describe everything about filter rules, about protocols and other stuff that you see here. So don't worry, have patience and follow me, put like, put comment, and let me know if you have enjoyed this video or not. See you by the next video.